Well, hey everybody, and welcome into Pushing the Limits. Today I have Dr. Dayan Goodenowe, and I'm just jumping out of my skin. We've had a fabulous conversation already. I've already learned so much. Thank you, Dr. Dayan, for already sharing so many pearls, and I thought we'd better get recording.
I know.
Welcome back to Pushing the Limits, Dr. Goodenowe. It's wonderful to have you.
Happy to be back. Wonderful to talk to you, Lisa. Looking forward to it.
And we've got so much to catch up on because you've been a busy bee in the last few years since we caught up last time and had our initial conversation, and I'll link to that in the show notes. But Dr. Goodenowe, can you just give us a brief backstory and then bring us, in a nutshell to where we are today so we can take the conversation forward from there?
For sure. Well, the interesting thing, from my perspective, my background is in science, right? My PhD is actually in medicine and psychiatric medicine, looking at the biochemical mechanisms of psychiatric disease. So I come at this not from an MD practitioner's perspective, but from a science perspective, right? And this is where I began. And a lot of people that get into this functional medicine and advanced, they all have something that happens in their life really that kind of changes them and says, you know what? I've a wake-up call, right? And they come from this medical perspective, right? Where and the medical profession is taught to diagnose, is taught to focus on disease, right? Because you're going in as a sick person, something's wrong with a person, okay? Healthy people don't go see the doctor, for example, right? So you're going to a doctor to find out what's wrong with you. And they're trained fundamentally to find disease. And you do find what you're looking for. Right. So they're not trained to find health. They're trained to find disease. Right. And so all of our technologies that have been developed, our blood tests, our diagnostics procedures, they're all designed to look for disease, find a disease, to diagnose a disease, to characterize and log people in. And they're never ever taught. They're not really taught about health. They're not taught about core nutrition. They're not taught about the core biochemical operations of the body, right? And so I come at it from a different direction, right? So my background, is doing clinical trials, large-scale clinical trials, like 50,000 people with colon cancer, and on and on and on. So the cancer space, the dementia space, and so on. And then from the pharmaceutical industry perspective, so my background is in biotech, in manufacturing or discovering, patenting products, right? And on the technology side. So I'm really a bricks and mortar guy, right? Not just really a practitioner perspective. So what I realized over the years that this really kind of was a wake-up call roughly back in 2016 is that enough already. I can't keep patenting these diagnostic tests for autism, for Alzheimer's, for Parkinson's, for colon cancer, pancreatic cancer, ovarian cancer, and developing these laboratory technologies that we can screen for these diseases, but they don't get implemented. So, and this what was very frustrating is that there's actually a lot of really good science out there. We just don't use it. And there's this big divide between the scientist side and the clinical trial side, and this part of, and there's a lot of things that are done well in that regard. Like we know how to actually validate, we know how to test a hypothesis, right? That's been going on for hundreds of years, right? That science side of it is there. And so we run these clinical trials and we identify, oh, here's a useful solution. But then there's this huge gap when it comes to getting implemented. Okay. And this is where my frustration, my wake-up call really was that this is enough already. I got to roll my sleeves up. I got to get in with the people here. I can't be sitting in some glass tower watching people live and die and just track their life and death from a scientific perspective. I got to really get in the trenches with the practitioners. And the practitioners need to have access to research level technology. Research level technology, not on the actual instrumentation side, like the ion cyclotron mass spectrometry side, the advanced research grade MRI technologies, but also advanced technologies in the manufacturing of certain core nutritional intermediates. And so I do basically biochemical engineering of the human body. So I don't deal with drugs anymore. A lot of the molecules that I invented and patented in the pharmaceutical space are biochemical intermediates. Some of the most advanced drugs in our world, like L-DOPA for Parkinson's, for example, that's a metabolite. Okay, that's actually a human metabolite. It's not a drug. Okay, it's actually in your body all the time, no matter, you don't need to take a drug like you need L-DOPA to restore dopamine levels, but that's a precursor to dopamine. And so we know these things, this basically, so L-DOPA is basically biochemical engineering for Parkinson's to restore dopamine levels in the substantia nigra and related pathways. So my job is to take that approach and to educate and to be able to bridge that gap between the practitioners who are diagnosing, and the really good ones, it's a bit of an art form, really. Like the really good practitioners out there, doctors functional med people, like the holistic approach of a human being is like you understand it, but it's really shocking how they never really get taught about health. And I tell people, if you fight disease, if you're always looking for disease, and the best you can achieve is a zero, right? Because you're trying to remove a negative from the system. Okay. And if you're 100% successful in removing all the negatives in your life, biochemically and otherwise, the best you can hope for is a zero. So I say, don't be a zero. Okay. You have to add more in, right? If you want more love in your life, you can't just remove hate to get more love. Like you actually have to add more love in. If you want more health, you have to add more health in. You have to add in what you're missing. And so this concept and then people realize that it's the deviation from health that leads to disease. Disease is not what causes a loss of health. A loss of health is what causes disease. And so the traditional infrastructure, and even our mindset, even when I have new clients that come through our door, right, they'll often come in with their diagnosis. I've been diagnosed with this. And you have to restart the conversation. And you say, okay, tell me how you feel. Tell me what works, what's working in your body, what's not working in your body. And let's restore function. So the restoration of function is disease independent. Okay, the brain is supposed to work, right? There's core systems in the human body that are designed to work. And our job is to restore them to the original manufacturing specifications. And if you actually, a heart cell is designed to do what a heart cell does. Okay, and oligodendrocyte in your brain is designed to myelinate your axons. Okay, if you provide it with the material and create the right environment for it to do its job, it will do its job. Okay, it wants to do its job. Okay, and so something's preventing it from doing its job. So when you start focusing on restoring health, it's a whole different ball game because disease is irrelevant. And it also it creates more of a unifying approach to things because once you deviate from health, that it just spreads out. So you can have the complexity. Disease is complex. Health is actually quite simple. Like it's not totally simple because the human body is quite complex, obviously, but we can break it into really core operating systems. And so we talk about membrane, we talk about plasmalogens and the membrane structure. We'll talk about that, but mitochondrial function, the methyltransferase system of the human body, peroxisomal function, muscle growth, development. These are the core systems that you need to have working. And if you have them working, not only can you restore health and maintain health, that you can achieve higher levels of function. And so a lot of it, people obviously are the most motivated people in our world are the people who are suffering from something, right? Someone gets ALS or someone gets multiple sclerosis or dementia, that kind of wakes them up and says, oh, I got a problem. So those are motivated individuals. And then you have this other group of individuals that are just trying to restore health and function, and they want to be, how do I maintain health? And so we do both of those areas, but my job is to really build infrastructure. We actually physically have magnetic resonant imaging MRIs, we have ion cyclotron, advanced laboratory testing. And so those technologies have really dramatically improved. And we just don't use them for academic research purposes. We actually use them in real people and getting them in the process. So that's kind of what's really happened over the last few years since our last conversation is really the ion cyclotron technology is coming online. This advanced MRI technology, the digitization of the human brain, like we can fully digitize the human brain now in a non-targeted way. And then the manufacturing capability of our plasmalogens, our comprehensive nutrition program, and then we have our center in Canada, which people physically come and live with us for 3 to 4 months with these serious diseases, and we're getting highly reproducible reversals in diseases like ALS and MS, and we're just kind of continuing to get better. And we want to disseminate that knowledge to our practitioner network and to everyone, that's out there, saying that there are systematic solutions to these situations, and anyone and everyone can take control of their health in this manner. So that's kind of what's been happening. So yeah, it has been
a lot happening.
software design and our ability to track. That's the other thing too, is like there's a lot of logistical infrastructural stuff, right? We're talking about longevity or immortality, right? You have to actually use the word functional immortality, because sometimes we're cautious. We'll say, oh, we're going to just do longevity research, right? But really the goal is, how do you maintain functional integrity indefinitely, right? How can your heart function forever? Can your brain function, do its function? Is there any reason why it can't continue to do the function it was designed to do indefinitely? And if you look at it from that perspective, there really isn't. There really is no barrier, okay, other than our own ignorance in terms of and our ability to maintain these operational programs and to be able to monitor the deviation from health. And that's where the advanced, testing technology comes in, because you need to know when something at the biochemical operational level is not working. Because people forget, like we take the human body is so robust that we take it for granted. But you're a bioreactor, right? You eat a hamburger and a milkshake, and your body makes your heart muscle and hair and and brain cells from that. Like your body converts all of that stuff, and it's an incredibly sophisticated bioreactor, and at some level, it's no different than brewing wine and beer. Like if you want, or it's a recipe, right? And so if you want to have sweet tasting wine, you got to put the right ingredients into it, and you got to create the right environment for that wine to mature. And at a conceptual level, the human body is the same way. And so it's just so that's kind of where my focus has been on. And we've got a lot of things happening, with A4M, and I do more lectures, and the awareness and our client base and our practitioner base is growing quite dramatically. So it's exciting to see these things, these stories, like especially like children with autism, or extreme success in those areas and so on. So there's a lot going on, but yeah, so we can kind of
we can dig into
the weeds wherever you want.
We're definitely going to dig into the weeds, but this is a fundamental shift in philosophy that we're trying to get across here. It's a deviation from health, is what disease is, and so people get tied up with the labeling, right? You've got Lewy body's dementia, you've got Alzheimer's dementia, you've got MS, you've got Parkinson's, but you sort of go a level up and go, what is health? How does health look like? And these symptomology for Parkinson's is really isolated to maybe this set of neurons here, but it's actually the biochemical reserve capacity of that person has gone down. And so you can even predict. So if we swap over now, talk a little bit about the plasmalogens, which are these essential phospholipids that are in the membranes of cells. They are phospholipids, aren't they? And these are a crucial part of the arsenal that you have in fighting everything. So we're talking to people that are, dealing with autism, Alzheimer's, Lewy bodies, Parkinson's, multiple sclerosis, myocarditis, post, COVID, long COVID syndromes. All of these things require plasmalogens, and you have made two products. Well, you've made many others, but two key products in the plasmalogens, the Neuro and the Glia, that I want to dive into today.
Yeah.
And then also the egg yolk oil that you've developed alongside it. And these are precursors that basically, I come from a firefighting family, right? So my husband's a firefighter, my dad was, my brother is, and you've got to have water for the firefighters to put the water on the fire, right? And that's what plasmalogens are, basically. They're made to be sacrificed. They're in the membranes of the cell. They're made to be sacrificed to put out whatever fire is going. If you've got no water in the lake, because you've just, been through a big sickness or illness or for whatever reason, then you're going to have no plasmalogens to put out the future fires. Is that a good way of conceptualizing what plasmalogens do?
That's exactly right. And so, you think about, you have this reservoir, this water reservoir that you have available to fight fires with, right? And this water reservoir is being fed by a small stream, for example, right? And over time, that small stream fills up this reservoir, which is your reserve capacity. And like you exactly said, like you get an acute event like a fire, and you go in, you tap into that reserve, and that's fine. So as long as you only use up a part of that reserve to fight the fire. And then there's a period of time between this fire and the next fire. And then that small stream that's feeding that reserve capacity gradually builds your reserve capacity back up. And then you're fine. So you have enough left over for the next fire. But if the fire goes on too long and too severe and you lose your reserve capacity, then you're stuck with only whatever is trickling in from the stream that's feeding, right? And that's usually not enough. And so filling up these reserve capacities is critical. And the plasmalogen story is really exciting because it is a true embodiment of this philosophy. Okay, these plasmalogens just didn't come out of, well, they actually did. They came out of thin air. Okay, it wasn't a hypothesis. It wasn't saying, I didn't go out looking for these plasmalogens, right? And I'm a neurochemist. My expert is in neurobiology, and I didn't even know what these things were in the early 2000s, right? So what really, where this was discovered was exactly this concept of this deviation from health. So one of my first patents was this advanced mass spectrometry technology. So we use Fourier transform ion cyclotron resonance mass spectrometry. It's a superconducting magnet. It allows us to, and we have two 7 Tesla systems here at our facility in Temecula, and it allows us to measure thousands and thousands of molecules simultaneously in human biochemistry. And so I invented this technology back over 20 years ago. Like, that's how long I've been doing this. Like, it's 25 years now when I first started doing this ion cyclotron work. So when I was applying it to dementia or cognitive decline in population base. So I used this technology to measure the comprehensive biochemistry of people with different degrees of cognitive impairment. And out of the thousands of molecules that were studied, these plasmalogens were discovered to be reproducibly decreased in the blood of individuals with cognitive impairment. And as I researched it more, it also predicted which people would become cognitively impaired in the future if they had low levels to begin with. And so this is where this kind of deviation from health mindset really comes into play, because that's exactly what it was. It was this and so these plasmalogens, the Alzheimer's disease doesn't necessarily cause a depletion in plasmalogens. A depletion in plasmalogen causes Alzheimer's. Yeah. And so this deviation, and that's the deviation from health concept. And so the advanced technology allows us to measure that. Then the next part of the process is, okay, what do we do about it? How do I restore plasmalogens? And plasmalogens, I didn't invent plasmalogens. They were discovered back in like 1919. And in the 70s, it was just really discovered that the peroxisome was critical for making these plasmalogens. And so there's certain diseases in children where they have genetic mutations that affect some peroxisomal enzymes. One of them in particular is called rhizomelic chondrodysplasia punctata, RCDP. These are children that have genetic mutations that prevent them from making plasmalogens. And it's a high mortality disease. It's an autosomal recessive disease. So you need a bad gene copy from both your mom and your dad. But then the child, if they have RCDP, typically don't live more than a few years. They can average lifespan is like 5 years. And if they have milder cases, it'll live longer. So we know for a fact that this plasmalogen system is critical for human life. Like if you don't have and they have dwarfism, they have skeletal defects, they have brain defects. Ultimately, they typically die of either heart failure or lung failure. And so we've now got really powerfully documented stories where we can restore plasmalogens in these children, and they are normal now. Like they're living, like they're not going to die. And so, in the one child, like little Thatcher, he's now taller than his older brother, for crying out loud. So you can actually restore health. Like you can bypass genetic defects if you know the biochemistry of the human system. And so we know about plasma. So the challenge now is, so they knew this back in the 70s, but there was no real viable way of restoring plasmalogens. The only real source of these, because the total, like your brain, 20-30% of all the phospholipids in your brain are plasmalogens, right? That's a lot. 50% in your heart, like your heart, lungs. So your body contains a lot of these things. So you're thinking, hey, if I'm eating animal products, why am I not getting enough plasmalogens, right? Can I just go eat heart material, or I can eat muscle material? And the problem is, what makes these plasmalogens so their superpower is that they're very powerful antioxidants. And the very last step that in the manufacture of them creates this bond called a vinyl ether bond, and which is what gives it its power to neutralize peroxides in your body and so on. Problem is that when you eat food that contains plasmalogens, your stomach has concentrated hydrochloric acid in it. So those things get broken apart and you can't absorb them. So you can't actually take a fully intact plasmalogen and get a benefit from it. So this is where my background in synthetic organic chemistry, and so medicinal chemistry approach was, well, how do we design a plasmalogen precursor that can be absorbed and be delivered to your brain, into your heart, into your lungs? And that's where my real contribution was in my patents in terms of the plasmalogen structure, was these plasmalogen precursors. And you tell these stories, right? And you think there's this linear path, but it's interesting that once you get into it, then you kind of go back and you look at other things, and you realize human breast milk is one of the most powerful sources of these plasmalogen precursors, and it really links. Yeah. And so these plasmalogen, yeah, which is why breastfeeding is linked to increased brain development in children, and increased myelination, and reduced rates of autism, and all that kind of stuff, right? Like, it's not a complete cure-all for sure, okay, but it does tell you, that scientifically tells you that there's a link between the composition of human breast milk. Like, there's virtually no plasmalogens in cow milk, for example, right? So when children are taking formula versus human breast milk, they're lacking certain core nutrition of their brain. So you think it's all linear, but you kind of go backwards in time and you say, now that I have these plasmalogen precursors, then you realize, well, they've been present in breast milk, but you can't get enough of them. So the prodrome glia, which is an omega-9, got oleic acid designed in it, and so it's got the plasmalogen backbone and oleic acid. That's the molecule that's actually in human breast milk. And then Prodrome Neuro, and so that's designed for white matter. It's more of a protective molecule. It restores the white matter of the brain, of your heart, your peripheral neuron system. Very, very potent anti-inflammatory, improves sleep, that type of thing. And then Neuro it's a plasmalogen backbone, but it has DHA, a long chain polyunsaturated. And that's for the neuromuscular junction and the synaptic function of the brain for neurogenesis perspective. So I tell people the two plasmalogen molecules, it's like an old radio. The glia is the tuning dial. Glia tunes your neurological signals and your health up, but it doesn't create volume. So you can get the radio station tuned on station. And people that are suffering from inflammatory diseases, they're basically in a noisy static, their body has a noisy staticky biochemistry. And so if you turn up the volume, it gets worse, right? Like like an old radio, if you have it kind of off the station and you crank the volume up, all you hear is crackle. And so if you keep the volume down low, you can kind of hear the noise behind, you can hear the music behind the noise, if you will, right? And that's what a lot of people are suffering from these chronic inflammatory diseases. They live in a really kind of a suppressed state. Any additional activity makes their disease worse. So neuro is the volume. And so once we tune, and so people suffering from long COVID, for example, we start with the glia to resolve the inflammation, restore function and structure, but their body has kind of maladapted to this lower energy state. And so the neuro is what really brings them out of their long COVID. So the neuro is the volume. So once you get the radio station tuned on station, then you can crank the volume up. Okay. And so
the volume before you've done the glia, basically.
Correct. You do the glia first, and you do the neuro second. And the neuro is really for enhanced neuromuscular performance, cognitive enhancement. It's one of the most advanced
Can I ask, so
advancement molecules.
If we list out a few of the common neuro diseases, so someone like my mum who's had aneurysm, stroke, concussions, cancer of the brain, she's had E. coli's, COVID, you name it, she's broken a hip, had operations, which is also an insult to the brain, blah blah blah. What would be the one to use first? So glia would be the one that you use first. That's what I was told by Dr. Youth, to use the glia first. But we're not. And like my mum's a miracle, and I credit a good portion of that to the plasmalogen use that we've been doing now for years. But I focused more on the glia than I have on the neuro for a couple of different reasons. So I knew that this picture of the glia, you have to get the information down before you tune up the volume. Also, the neuro is quite expensive, so like I was trying to work out how the glia is a lot more manageable, so to speak. So I can go higher doses than I could with the neuro from the get go. But you do need the both of them really with a complicated history like that, you would need the both of them in the mix in order to get the volume. Like she's got a shrunken brain, like her brain is shrunk. When you look at the MRIs, the scans, there's those cracks in the brain that you can sort of see in a shrinkage in the brain. So that's a loss of volume. That's the choline system.
Well, it's a plasmalogen system. So in terms of your mom, for example, right? So there's the glia is about bringing things back up to baseline. And the neuro, when you're increasing performance, you're increasing performance not just in physical athletic performance, but you're actually increasing performance of health, cleaning, cleansing, the reverse transport cholesterol system. All these things happen. The neurovascular system. So in terms of clearing the system and then stimulating the growth of the brain, okay, so the size of the brain is determined by two things. One, notice my connection is
well, that's pretty good. I think we're
so the one is like the volume of the brain is determined by the actual cellular content. So you need the cells of the body. So you need neurogenesis, and then the plumpness of those cells, okay, is what all brings up the volume. Okay, not from a inflammatory swelling perspective. So neuro is really what drives the neurogenesis part. Okay, in turn, growing the brain, neuro grows the brain. And it does it by a very specific mechanism. It actually stimulates a peptide called secretory alpha and similar precursor protein, which is, people worry because it's got amyloid, but that's not the case. APP alpha actually is your neurogenesis peptide of the brain. Anyway, so it does that stuff. So, and also just clearing out cancer. So for all cancers, so to get deep in the weeds, so cancer disease where the mitochondrial production of ATP is impaired. And so what happens is your cells use extra mitochondria. This is where people have with the Warburg effect and all these other things with the biochemistry. So the biochemistry of cancer has been extensively studied. Basically shows that the cells operate in a fed state versus a fasting state, and which means it kind of shuts off your peroxidase function. This is why people with cancer will often have muscle wasting, for example. So sarcopenia, that type of thing that happens, because that's all built from your peroxisomal system. And plasmalogens are made in your peroxisomes. So virtually all cancers have a plasmalogen deficit. Okay, that's one of the biggest findings so virtually all cancers have a plasmalogen deficit. So Prodrome Neuro is really the main one there because it improves cholesterol transport. So the cholesterol transport system, you want to make sure that their HDL levels get up, and you want good high levels of cholesterol. So blood cholesterol level well over 200 using the US system. I can't think of the conversion for the metric version, but you want to be on the US version high. You should be in the 240 range, if you will. So you want good levels of LDL, you want good levels of HDL, because the cellular membrane structure is important. So that's where that goes in. So this is where the concept of deviation from health is. So a fasting cell, there's certain parts of your body that never get cancer, for example. Like you virtually never get cancer of muscles. You virtually never get cancer of the heart. Okay, the only time the heart ever gets any cancer is if it's a metastatic from some other part of the body. And that's because your muscles and your heart live in the fasting state. They live off of fundamentally fatty acid metabolism. And so one of the main aspects of cancer is shifting the body into a fasting state and then getting the mitochondrial function, the ATP production, putting it back in the mitochondria. So I use things like rapamycin and ivermectin in combination with, high dose of the Neuro and glia, of course, but the mitochondrial support structure, like your good old B1, thiamine, riboflavin, niacin, higher doses of niacin. People don't take enough niacin. Good, cheap, old-fashioned nicotinic acid, like the flushing kind. Like you should be up to basically a gram a day people should be taking.
Really?
Creatine is another simple, cheap supplement that people should all be on 4 or 5 grams of creatine every day. So when I talk about health, what are the core areas that have health issues? And it is the mitochondrial structure and function, okay, which is your main powerhouse of your cells. It is the methyltransferase system. So when you talk about phosphatidylcholine, okay, that's another big, big issue. So that's why we've spent a lot of time. That's another one of our products that we focus on. And it's the animal-based phosphatidylcholine that is really critical because it's what the brain can absorb. Okay, the seed oil-based phosphatidylcholine is not human compatible. Like it requires a lot additional biochemical transformations. It requires an enzyme called phospholipase A1, which is really in the liver. The brain does not absorb plant-based phosphatidylcholine very well because it's got linoleic acid at the SN1 position. Getting in the weeds type of thing. So we focus on trying to find high concentration animal sources of phosphatidylcholine, and the best place is egg yolks. Is one of the best sources of it. And so we use fresh frozen egg yolks, freeze dried, and then we extract out of that using food grade ethanol the full lipid composition of egg yolks. And so we use that. We have what's called a phosphatidylcholine. So there's a Neuro PC Plus product and a Glia PC Plus, which contains additional brain nutrition, which has these animal-based lipids that are highly absorbable into the brain for restoring brain volume and structure. That's the other aspect of it. It's also
choline's super important, isn't it? Because when you don't have enough of that choline, methyltransferase system's not working, you're sort of digesting your own membranes. Is that correct? Like in the
That's
brain?
exactly right. So the methyltransferase system is one of the weak links in the human body. You have a fairly robust one, but there's two molecules that take up the bulk of your methyltransferase system. And people think when people think about methyltransferase, they normally think about homocysteine levels, so elevated homocysteine, which
Yes.
is a pretty decent marker.
Yeah.
Actually, low levels of homocysteine are equally bad
Right.
because it shows that you have a problem doing methyltransferase. But the two key molecules for methyltransferase is making creatine for your muscles and your brain and your liver, and making phosphatidylcholine. And so the reason why supplementation with phosphatidylcholine is so important and with creatine is so important is that it provides a reserve capacity. So by providing those molecules nutritionally, you are relieving or you're reducing the methyltransferase demand of the body. Okay. And it reduces those quite dramatically. And so this is the other concept people need to get kind of work on, because we have what's called essential nutrients and non-essential nutrients. But that definition is derived from acute studies of deficiencies. Like, a vitamin D deficiency will give you rickets, or a vitamin C deficiency will give you scurvy. And so a choline deficiency, your body can technically make choline. Your body can technically make creatine. Okay. So it's not considered an essential because your body can make them. Same thing with plasmalogens. Okay. It's not considered essential because your body technically can make them. But can you make enough of them for optimal health? And that's really the different part of the conversation, is saying, well, no, your body, a lot of these vitamins, it's not possible to, in a nutritional perspective, get enough. Like, you can't get enough niacin in a regular diet. Riboflavin is another big problem. Riboflavin is critical for absorbing your minerals and nutrients, critical for your electron transport chain. It's a critical nutrient, and it's cheap as dirt. A lot of these basic B vitamins, and so before people get into really fancy stuff, you want to also make sure that, again, this concept of the human body as a bioreactor, there are a lot of ingredients required to make the human body function. It's like a recipe, right? A good recipe has lots of ingredients, and your human body is a very big ingredient list. And so, and getting those core systems in place, they're synergistic with each other. Okay. N-acetylcysteine to maintain your glutathione levels is another area that's important. People.
Can I ask a couple of questions there? Niacin, doesn't niacin deplete methyl groups if you have too much of it?
Well, it gets methylated, okay, in the process of making NAD, but not really that big of a deal. You want to take your branched chain amino acid, like leucine and niacin together, are very important. But if you're taking creatine and phosphatidylcholine, and then on the methyltransferase support, you want to have your N-acetylcysteine, you want to have methylfolate, methyl B12, and also trimethylglycine. That should also be part of your dietary. And so you just want to make sure you have enough of those things. And if you have enough of those things, then you don't need to worry about niacin. Like, niacin is actually amazing anti-cancer. Virtually all chemotherapeutics, all cancer therapy trials that have added niacin to the regimen has improved outcomes in cancer, virtually every single time.
Wow.
And it used to be used a lot for lipid lowering. So niacin is also, so if people have so when you have low HDL individuals, right? So people that have low levels of HDL, there's usually a trifecta that you use to try to increase HDL levels. So Prodrome Neuro, the animal-based phosphatidylcholine, and niacin. Those are the three nutrients that reproducibly increase HDL levels.
Wow.
And niacin is also very powerful at lowering your triglycerides. So it used to be used up to 3 grams a day was the therapeutic dose of niacin. Now, of course, don't do that all. I tell you, don't do that at once. You want to build up. because
I
it does
did that.
flush. Yeah.
Yeah, I went too high with an ice all at once and ended up in an
Yeah.
ambulance. So don't
Yeah.
do that.
Just interrupting your show to let you know about our Health Span Hacks course, How Not to Die. This is a comprehensive course created and produced by myself and world-renowned cellular health and regenerative medicine specialist, Dr. Elizabeth Yurth, founder of the Boulder Longevity Institute. Now, this course unlocks the latest on the science of anti-aging, longevity medicine, and cellular health, equipping you with the tools and the insights to improve your health span and vitality. Together, Dr. Yurth and I have provided evidence-based strategies to optimize your body and mind, empowering you to live a longer, healthier life. So enroll today at lisatamati.com and start transforming your future, or check out the link below in the description.
These are key. So just to reflect back, these are key mitochondrial support alongside the plasmalogens is really key,
Yes.
so that we get our methylation system working as well and our mitochondria working. What's your take on guanoacetic acid as opposed to normal creatine? I've heard that it's very much, well, it gets into the brain easier, and taken as a combination of normal sort of monohydrate creatine with guano, how do you say it, GAA.
Yeah.
Is that a better form of creatine if you're taking creatine if you've got
No.
no?
You know, GAA, I strongly recommend against GAA therapy.
Right.
So GAA therapy is like taking L-DOPA. Okay, the process, GAA is the actual main methyltransferase drag, because it's actually GAA that gets methylated to creatine. So if you take GAA, you're actually sucking up excess methyl groups. And that's why, so for example, if you take Parkinson's, for example, people take L-DOPA. So they'll often take a COMT inhibitor, so catechol O-methyltransferase inhibitor, because it's converted to dopamine, but it also creates elevated homocysteine levels. So GAA, if you take GAA directly, it'll elevate your homocysteine levels.
We have GAA with, well, this is what I've heard. I interviewed a guy who formulated a GAA with a different type of creatine, the normal creatine, to buffer that effect. That was more, well, his take was it was more beneficial in the brain if you were buffering that methyl problem.
No, your brain has high levels of creatine. Okay,
right.
It's as a metabolite, when you do a magnetic resonance spectroscopy, MRS, the creatine peak is one of the biggest peaks in MRS. Okay, and so your brain absorbs and takes up creatine quite dramatically. I wouldn't so when we look at our protocols, when you're taking the plasmalogens, you're taking creatine, and so you'll see your your glutathione levels in the brain elevate. And so that would be, it gets converted to creatine for sure, but you're putting a load on the human system that I would not.
Okay.
So I try to get people off of those like same thing with Parkinson's. If we support the system functionally, people can get off of L-DOPA even. Like we can actually, because it has other side effects. So.
Yeah, exactly. And N-acetylcysteine is another key one, which is also a precursor to glutathione. Again, when you bring in precursors, they seem to do better in the body, don't they? In a lot of cases, like
because so the N-acetylcysteine is okay. So look, N-acetylcysteine is just it's an amino acid. It's cysteine. So sulfur amino acids, like your cysteine and methionine, are critical. You don't want to take methionine directly though, because that again has some issues with it. So if you take N-acetylcysteine, then you don't really need to worry about methionine. So methionine is your actual methyl donor that the body uses. So methionine is an amino acid. It's found in your proteins. It's low, typically. These sulfur amino acids, methionine and creatine, methionine and cysteine, are typically low in plant-based proteins. They're higher in, say, whey protein, for example. But N-acetylcysteine, it restores your cysteine levels, restores glutathione levels. And one of the problems with inflammation, so people that are suffering from inflammation, is not just that you have reduced levels of glutathione. It's that your body has the glutamate toxicity of an inflamed microglia or inflamed macrophage, for example. It actually starves your cells of cysteine. So one of the mechanisms, how it actually kills damaged cells, is by hitting it with lots of glutamate, and it sucks the cysteine out of it. So when you want to, because it's called the cysteine antiporter, is the actual protein. It actually pulls up cysteine, or cysteine, if you will, pulls up cysteine, and it exports glutamate. And so by taking N-acetylcysteine, it's not about just the glutathione itself, but it's actually cysteine that has importance, because you want to make sure that you're counteracting the inflammatory response of the inflamed cells. So yeah, N-acetylcysteine is one of the most well-studied, and people don't take enough of it. I take 3 grams of that a day. Like I'll take 6 capsules.
Okay.
And so it's one that, study after study on N-acetylcysteine, it's one of the most powerful. The other one is carnitine. Acetyl L-carnitine is another really, and coenzyme Q10. These are other molecules that have to be in your arsenal
Do
over
you
time.
take sort of higher doses of those as well? And the question on the back of that, the coenzyme Q10 is a big molecule that's quite difficult to get into the cell. Is there any particular preferred form? Like I interviewed Dr. Barry Tan, who has geranyl, which is a sort of part of the coenzyme Q10 molecule that he says gets into the cell much easier to make the actual coenzyme Q10, because it's a bit of an albatross of a molecule, isn't it? The coenzyme Q10.
Well, CoQ10 is actually, it's actually a fairly simple molecule. It's a tri-ring. It's polyene molecule, which gives it its antioxidant. So in its active state, it has 2 ketones on it. And so how your body uses coenzyme Q10 is in your electron transport chain. So your electron transport chain has 4 compartments in it, and then the 5th one is the ATP generating system. So NADH is your human energy. And when your body combusts hydrocarbons like sugars, fats, it brings it down to a simple molecule called acetyl-CoA. Then acetyl-CoA gets burned into carbon dioxide and water. And when it gets burned up, so that we can actually have this conversation, right, this energy that it creates creates electrons and protons, proton being H plus electrons. And so it transfers those electrons onto NADH. So NADH is actually the human form of energy. And so then the body takes this NADH, the energy is stored in NADH, and it transfers the energy in NADH into the electron transport chain, and it transfers it to coenzyme Q10. And this is where riboflavin becomes very important. A riboflavin works hand in hand with CoQ10. It's riboflavin that actually is actually what transports the electrons from NADH onto CoQ10. So then CoQ10 becomes ubiquinol, and then CoQ10 takes those electrons and it transfers it. So that's at the complex 2, and then it transfers it to cytochrome C at complex 3. So it shuttles it in that process. And again, I think people get bored with 50, 60, 70 years of science, and they always try to find new things. But really, coenzyme Q10, if you're taking a couple 100 milligrams of that per day, like you can take fairly well doses of it, it's going to get to where it's going. I don't think you have to worry too much about that.
Versus ubiquinol doesn't really matter.
Well, I simply use coenzyme Q10. Right. Again, people think, well, niacin and versus different types of NAD precursors. If you're taking sufficient levels, okay, over time, it will improve it. So 1 gram of niacin per day, okay, will elevate your NAD levels, both in the blood and in your cells, by 3-fold over a few months, okay? And so when we talk about longevity, And you talk about how do you maintain basically functional immortality of your cells? That's not a 1 week job. Okay, this is something that you're going to have. You're creating a sustained biochemical environment, and so you're adding these things in, and you're taking them long term. And if you're taking these things long term, okay, your body will gradually build those things up in their right form. So sometimes the studies that we do, these short-term studies, if we're comparing directly the bioavailability of one versus another and say, whoa, the bioavailability is better. Well, does it really, is 40% versus 60%, does that make any difference long term? I guess because 40% is probably maybe all you need, or you take 10% more of it type of thing, right? And so, and the other things with your gut function will evolve. So we got to be careful when we micro dissect some of these studies, because we look at these studies scientifically, we're trying to understand things at a mechanistic level. But when you're applying it in your everyday life, okay, those things, your program, your personal program, you look at it long term. What are the long-term programs of it? And then in my personal opinion is I like to keep it as simple as possible. There's enough complexities out there. Keep this program simple. Where you want to get fancy is if you want to get fancy into peptides or into other types of triggering or signaling. When you want to change your environment in a way that you are stressing or you're pushing the system in a certain way. That's where things get a little more fancy.
So looking at going back to the plasmalogen story, we want to create this biochemical reserve in the body. So we want to be putting these in, whether you're healthy or you're fighting a disease. And if you're fighting a disease, you may want much bigger doses depending on what you're facing. And if you're facing something like ALS or Parkinson's, then you better get serious. And then you've got the mitochondrial support. And then there are other things which you could be adding in. And I've heard in a couple of your lectures when you're talking about autism and dealing, with children who are having these incredible breakthroughs with plasmalogens and mitochondrial support, but you fix the brain, but then there's also the rehab journey, isn't it? Because you've actually, it's like with my mum, I've got her back to a certain level of function, but I have to train her constantly. I have to keep changing up the exercises she does or whatever, the rehabilitation, the training at the gym, the weight training, all of that sort of thing, because I need to put in the impetus, because the body has lost that ability. So if you're dealing with Parkinson's, you're dealing with ALS or these things, you've got that rehab side of the journey as well as the biochemical fixing of the biochemistry.
Everything is cyclic and rhythmic. Okay, there's no such thing as homeostasis, for example. Okay, that's a falsehood. You are never really in homeostasis ever. Okay, your body is changing over the course of the day. You're in a fed state, then you're in a fasting state, you're in a sleep state, then you're in a wake state, and so you're constantly you're changing. Okay, and so our job as stewards of our bodies is to create the stimulating environment so that we are being pushed and the body has something to resist against, because without the resistance, we get atrophy. So the human body has to work. It has to move. It has to think. There is no such thing as retirement. If you want to live forever, you want to be longevity, okay, there is no such thing as retirement, okay? You should be 85 years old and you should be thinking of what is my next university degree going to be? Okay, what is my next challenge in life going to be? Okay, and so you should never be, the concept of retirement is accepting your own death, right?
Yes.
And basically, you're basically you've already given yourself a window of time to die. Okay, so you have to first of all eliminate that from your system.
Yeah, totally.
So, and when you look at these things like restoring, from a disease perspective, obviously I take high doses of certain things, and I measure my brain with MRI, and I've presented this work where I've reversed over 20 years of my own brain aging and my own physiology. I'm 55 now, but I function better than I did in my 20s and 30s. My strength and my performance is better than it was, and my brain is now back in a 40-year-old state type of thing, and so these are things that we can actually quantifiably measure and do. Okay, we can measure health comprehensively and function, and we can then adapt and adjust our biochemistry and our environment in such a way to maintain that function, and it should be indefinitely. So, ask me again in 100 years how it's going. So that the whole plan is to, and why, and and it's fun. So, it's fun to push the limits, if you will.
Well, you're constantly learning. And, there was this concept I heard you talking on your podcast of entropy. Like the world conspires to disintegrate things. Like if you make your bed, was the analogy that you used, you make it nice and smooth in the morning, it's all made up, but there 100,000 things over the day will cause that bed to be mucked up again. And so we have to, if you're bringing that into a life, into health, there are things that are constantly trying to wear our health down, and we have to keep making the bed. We have to keep maintaining our health, because the world just disintegrates everything into chaos eventually. So we have to keep that active, proactive prevention mindset, alive and well, really.
And you have to be constantly pushing it, like pushing it within your limits, right? Like you have to actually. Your body needs the biochemical energy to do work. Okay. And so, yes, exactly those concepts. And so the entropy thing, that's what you're doing every day with your with the biochemical energy that your human body is producing. You're fighting entropy. You're putting order. Okay. You're actually creating order, and order takes energy. Mm-hmm. Cleaning your house takes energy. Anything, like you said, that's exactly right. The entropy kind of just, everything conspires to make things ashes to ashes, dust to dust, right? And so we're fighting that every single day. Yeah,
I think that's a really good analogy for people to have. Can we just before we wrap up, because I know you've probably got 1,000 other appointments to get to and stuff. Just you have the Prodrome scan. Can you explain a little bit why, what the Prodrome scan is, how it relates to, health and what you can read from it, what your practitioner can help you understand from this test? This is a functional test that you've developed. And how do the plasmalogens play into that?
Yeah, so a Prodrome scan is kind of the top, it's the greatest hits, if you will, of all the biochemical markers that I've studied over, tens of thousands, 50,000 more blood samples over the years. And so it's kind of your starting point of biochemical health. And so it has a section that deals with the phospholipids, like the plasmalogens, the ethanolamines, phosphocholine, and their compositions. It has a section that deals with the essential fatty acids that are at your SN2 position of your phospholipids that really indicate whether you're getting pro-resolving metabolites in your cells or pro-inflammatory cell metabolites in your cells. And it looks at the fatty acid elongation rates. We look at some gut health markers, these gastrointestinal tract acids called GTAs that are really highly predictive or high risk factors for colon, pancreatic cancer, for example. And then we have a section on the methyltransferase system that I've talked about already today, is very important. Not just the homocysteine levels, but ceramides and single myelins, and then your ethanolamines and cholines. That kind of shows you how your methyltransferase system is working. There's a simple mitochondrial testing section that basically looks at acetyl-CoA leakage out of your mitochondria. So your mitochondria is supposed to take in acetyl-CoA and create energy. And if it's overwhelmed, it's not doing its job or can't do its job, this acetyl-CoA leaks out and goes into, so we can measure that process. Looks at peroxisomal function, your plasmalogen levels again, and your DHA to EPA ratios, and your fasting triglycerides. We've just incorporated fasting insulin and fasting glucose as part of the test. Then we have an antioxidant panel. We just added the catalase, superoxide dismutase, and malondialdehyde. to the Prodrome scan test, so we have a really good measure of those antioxidant enzyme systems, and high sensitivity C-reactive protein is another molecule that we track because you want to keep that under 1. And then the cholesterol transport system, very simple, your total cholesterol and HDL is really the key markers there. And we look at some kidney NAD markers. So in terms of creatinine, blood urea nitrogen, and the uric acid levels. And so these core systems collectively are your core operating system of the human body. And we know what those are supposed to be. And it's not a diagnostic test. It's about function. And we actually, we restore health and function. Our protocols to restore these systems, we use the Prodrome scan test really to monitor our progress to optimizing our biochemical health. It's not saying, oh, based upon this, I do this. We're not taking the blood test to say, oh, because I have high homocysteine, then I guess I better take my B12. No, take your B12 anyways. Like you still take the core systems that your body has. And if you're doing those things, you use the blood test to monitor, oh, my homocysteine has gone from 14 to 12 to 10 to 8, 9, and now it's where it's supposed to be, right? So the blood test is designed to relieve your health anxiety over time. Okay, because the normality. So once you've identified a health program that fits your life, this blood test should show that, and then you should be able to check it. It gets rid of the boogeyman, if you will. Like once it shows things that could be totally out in left field that you didn't know was missing, and then that's kind of what the Prodrome scan test is designed for.
And it's developed even further since I did the last one, by the sounds of it. So this is a really good way to check that you're on track. The stuff that you're doing is working, and what to double down on, and over trend data over time. Because this is the thing, we don't. You go to the doctor, you ask for a blood test, and they go, "What do you want that for?" And you go, "Well,
yeah, I know.
No, we're flying blind if we don't have." Like you wouldn't drive a car without a dashboard, right? And this is a very, very fancy dashboard that gives us a real good look under the cover. And, I mean, I would love to see everybody just getting a basic blood workup. Would be good.
Exactly. Then we biobank your samples here, so we don't throw them away. And so we can go back into them later on. And then we've just launched the Elite program, and then that's the full ion cyclotron technology. So that's talking 50, 60,000 biomarkers. Okay. So it goes from that Prodrome scan to, and then we'll have our hormone panel, and we do enantiomeric separation of amino acids like D and L serine, which is critical. But so the full power of the ion cyclotron technology and the bioinformatics to interpret that are now becoming available to our elite practitioners. And then we have a parallel system with the MRI. So we have the most comprehensive MRI capabilities of the brain. So we measure about 10 or 12 different sequences of the brain, from the white matter to the gray matter, microstructure, structural connectivity of the brain, functional connectivity of the brain, biochemical composition of the brain. And so we have a very extensive digitization of the human brain. We measure about 100,000 features in the human brain. And we can measure that, again, to show progress over time. So we can show the reversal of age, the restoration of function of the brain, and then ultimately to show the maintenance of the brain. So we want to move the brain to optimal function, and then we want to monitor it over the rest of your lifetime that it should stay there. Okay. And that's where we're doing. So the advanced biochemical analysis and advanced imagery technology is really complementary to each other.
MRI coming to Australia shortly, one of these special MRIs that you've developed.
Yes.
And what I'm hoping any practitioners that are listening to this in New Zealand who want to go and do the elite level training, there's 2 levels of training that practitioners can do. I'm hoping to do the first level, but the second level you have to actually go to America and do part of it, live with you. But can you just walk through any practitioners what they could do to actually get qualified so that they can actually use all this technology? Because this is like we're talking. I mean, I've seen the testimonials from the people that have been through your Restorative Health Centre in Canada, your Parkinson's people, your multiple sclerosis, your ALS. These are diseases where you're not meant to come back from, right? It's a one-way street, and you're reversing these diseases. This gives people hope. So what we need is more practitioners understanding these scans, these prodrome scans, understanding these functional, this MRI imaging that you've done. So where can people go to find, if they're interested in doing the courses with you?
So either at prodrome.com, okay, the practitioners are technically in the Prodrome system. Okay, so prodrome.com, you'll have access to either the certified practitioner or the elite. So certified practitioners get a bunch of educational content. We've just now put all of my lectures and all of the scientific, because I do grand rounds every month on a different topic. Okay, and we'll talk about hot topics. We'll talk about alpha-ketoglutarate or methylene blue, or there'll be hot topics on things. And that scientific lectures, those are all available, all the history of those things. So I've been doing this for several years now. So there are years worth of lectures and grand rounds that are all digitized and searchable and indexed. So certified practitioners not only get educational training on the biochemical basis of these different diseases, but they have access to the historical record of all this content that we've done. And then every month we have our grand rounds. And then now with this new circle.so platform that we've incorporated, we can share and communicate with each other on our case studies and interpretations and outcomes, and hot topics are now communicated within that network. And so it's a very, very extremely powerful resource. And then the elite network is one step above that. That's getting into really high level research grade technologies.
Yeah, and this is where you
have protocols
to actually do part of that in person with you. But we need clinicians all over the world doing this, and we need both levels, ones that are just going to do the scans and use these plasmalogens properly and protocols properly, and so I'm really excited because I've seen with my own mother, of course, that I've been told so many times it's one-way street, put her on end-of-life care, she's not going to come back from this is terminal, this is blah, blah, blah. Wrong. Her brain's come back again and again and again. We've got some deficits now, but I'm still I'm not ever giving up, right? These are solvable, and with the more education that I get, the more things that I can put into the right combinations and the right things, I believe we can still get on top of the existing issues we still have. And the message that I want to get across to people is, just because you've been given a diagnosis of Parkinson's or Alzheimer's or something, or cancer, or a terminal cancer, and you've got your own story with your own father, this is not an end. This is not the end of the story. It's not the end of the road, and there is things out there, and it requires massive undertaking. Sometimes it takes a lot of effort. It's all hands on deck, as you say. Approach. You need a support network. You need some resources. It's unfortunately you need resources because not all this stuff is funded. But there is a way out, and there is a way forward, and there is hope. Most importantly.
Exactly. Life is very, very powerful. Life is binary. This is really what we're talking about here. Is a true celebration of life, right? It's very precious and it's very powerful. And if you support it, it reaps its rewards. There's no greater return on investment than your health, mental health, your physical health, and it's respecting just the enormous, awesomeness of human health. Like the more you learn about human health, the more you learn about the miracle of actually being alive, like how this actually works. And then you're either alive or dead. You can't be both. So if you're breathing, there's hope. There is, you just need to light the fire, get a spark, fan the flame, and work. Like what you said, like it's not easy, but with applied effort, it's, really amazing things are possible.
Especially when you have incredible people like you on the planet that have just spanned so many facets and just brought so much, inventions to the world, and these nutritional products to the world, and so that we can guide us, that we can actually, and this many others as well in the space doing incredible things. So never give up just because your local doctor doesn't know the answer. They're not the world, they're not. Correct. Dr. Goodenowe, and they don't even know about Dr. Goodenowe, I can guarantee you that much.
Yeah.
So you need to go and be proactive. Oh, Dr. Dayan, you've just been wonderful today. I don't want to take up any more of your time because I know you've got plenty of things to be doing. But I just want to say thank you for all the hard work that you continue to put into this. I'm hopeful I can do the training, at least the certified practitioner training with you. And I can hopefully convince some colleagues to fly over and do the elite level training so that we can get Kiwis more access to this type of thing. And if you are wanting to get the plasmalogens, you can reach out to me. We can do all of that. And if you're wanting to know about the Restorative Health Centre in Canada, what can people do? Because you do take a small number of people through your program. How do people qualify for such a thing, and if they're interested? And
if you go to the Dr. Goodenowe, so drgoodenowe.com, there'll be information there. There's sign-up sheets there, and someone will reach out to you and schedule an appointment. Lots of resources that are available there. And for us, it's like like yourself, Lisa, is just getting out there to communicate, for people to realize, like, we as a community, we just need to keep on telling our stories, and this will eventually become standard of care. Okay, I'm really interested ultimately, like, obviously, this is, like you said, these are not funded resources, but I'm really interested in public health. I'm starting huge community trials in a city called Moose Jaw, Canada. And so these technologies collectively, when we start really showing these results in a systematic manner, we will eventually change standard of care.
Yeah, and you have to start. It all starts with private, because you democratize these technologies over time and bring the price down as you scale things up and so on. But you've got to start somewhere, right?
Right.
And there's so much logistical hurdles to overcome, and getting this thing as a standard of care. When I hear the word standard of care currently, I think 30 years old.
Yeah.
That's what I see. Definitely. It's not what it currently should be. So if you've been offered standard of care, run for the hills and try and find somewhere else.
I know. But yeah, we're getting there. We're getting there. And so we just have to do the hard work and do the communication, show the results, do the trials. Like, there's no easy way. There's no shortcuts in this world. We as a community have to actually do the work to get this done. And so, you're critical to it, Lisa, and people like you out there talking and sharing our stories. It's just, it's changing people's awareness and vision. So
absolutely, that's why I keep
hats off to you.
I'll keep working. I'll keep sharing. And thank you so much for your time today, Dr. Goodenowe. It's been absolutely wonderful.
You're very welcome, Lisa. Have a wonderful day.
Thanks so much for watching, and we hope you enjoyed this video. Please like, comment, hit the notification bell and subscribe, and of course share it with just one person who you think could really benefit from this content. Click here to watch last week's episode, and click here for my website, and click here to watch a video you may not have seen yet.